Hello, everyone. A quick video on AI. I have a lot of thoughts on AI, but today I want to talk about whether AI can be used sustainably. Okay, and let's just go for it. Uh, so I did some really rough back of the envelope calculations, and I considered Kimi K3, which is kind of the frontier model right now, as the baseline. Uh, the reason I chose that and not OpenAI or Anthropic models because we don't really know how long, like how big they are, and because of that, it's kind of hard to understand, how they are run. But open weights, frontier models like Kimi K3, like we know their parameters. Okay, so Kimi K3 is 2.8 trillion parameters. About 100 are active. Uh, don't worry about all this, but just bear with me, okay? And to actually store this model and to run it, okay, you need 1.8 TB VRAM. Okay, so you need a GPU which is 1800 gigabytes. Okay, which is obviously not possible without a data center, right? Uh, to run it, okay, for example, right, like you actually, if you have to run it, it would take about 22 NVIDIA H100 GPU units. Each of them are about 80 GB, and then you cluster them together, and then you can run this model on it. Okay, so and even to run it for an hour, okay, it's going to take 21 kilowatt hour of power. Okay, so that's a big power consumption. And if we apply a very conservative rule of thumb of about 1 liter per kilowatt hour in terms of water consumption, and this is directly, okay, for cooling. We're not talking about the indirect water consumption, which is much larger. Okay, uh, it's costing about 21 liters, right? Uh, Now, this at a large scale is, of course, not sustainable. But uh, here's the solution, right? Like, which is local LLMs, okay, local large language models, and I've been experimenting them, okay, for months now. They can be installed on your laptop. It can be Mac, it can be Windows, it can be Linux, or if you don't have a powerful laptop with a GPU, you can have a desktop. Okay, and don't rush into buying one right now. Okay, I'll describe that later. But the point being, it's air cooled, right? So you're not actually using water directly for cooling. It's also super energy efficient. Okay, so for example, the desktop that I have, it is only 240 watt hours, so it's 88 times more efficient than Kimi K3. Uh, it's local, right? So it's completely offline. I can turn off the internet and use it. It's private, right? And it's free, right? So all, like, too good to be true, right? But are they good, right? Like, is it as good as Anthropic's, Opus, or Mythos or other things? And I've been experimenting with them for months now, and they get things done. However, last week was a game changer, and that is the main reason why I'm doing this video, because last time Alibaba released Qwen 3.8 27B, 27 billion parameter model, and again 27B with its full context, takes up 50 times less space than Kimi K3. Okay, so you can, so in that data center where you're running one Kimi K3, you can run 50 of these, right? But of course, you can actually also run them on laptop and desktop, right? Uh, So let's compare them, okay? This website is called Artificial Analysis. It kind of compares models together for their intelligence, and a lot of other aspects. And this is Kimi K3 here. The individual models are kind of faded because I want to show you the Pareto line. Okay, Pareto line is kind of the where is the optimal balance, right, between the total parameters, meaning how big the model is, how much GPU it needs, versus its intelligence, how it can be, how useful it is. So Kimi K3 is here, right? And as I said, there are small models as well as large models. Kimi K3 is one of the larger models, the frontiers. But last week's Qwen's release is right here, right? So it's about 52 versus Kimi K3's 60, and look at the jump, right? Like so, and all this is runnable on a laptop, okay? So we are getting nearly as good performance as a frontier model, while the model can be run from our own machine. But what about Claude, right? Anthropic. And so this is last week's release, Qwen 27B. It's got intelligence rating of 52. It is still behind the current frontier from Anthropic, which is Opus 5, which sits at 63. But like literally just 4 months ago, right? The frontier was Opus 4.6, and it had the intelligence of 45. So what I'm getting at is like literally within 4 months, what you could do only in a large data center, you can now do on your laptop. This is crazy. There is also a lot of implications for data centers and the AI bubble and all that, but I'll talk about it later. What I want to now show you is this is good, but a lot of companies are benchmarking their models, meaning they are kind of training them so that they would show up in these benchmarks as really smart. Facebook actually tried to do that, and it really backfired some time ago. Not surprising. So is it really benchmarked, or it can be actually used in real world situation? So as I said, I've been experimenting with these. I've been using them for months now. I have my own kind of a standard test wherein I actually use one of my research papers from last year and try to reproduce some of the results. I imagine that I don't know how to code, and see what the model does. Of course, it is my research, so I know exactly how to guide the model, but the prompts that I gave, everything is one shot. One shot meaning I'll give a prompt, do this, do that, don't do this, don't do that, okay? And the model has to actually follow all of that, okay, and give me a result. And I'm not asking it to do, and I'm not again intervening and hey, what were you doing, or nothing like that. Just one shot, right? And see what it gives out. Okay, so local models have been pretty good, but this particular release basically nailed it. So this is from my continental drawing paper from last year from Science Advances. Of course, this is not all the results, only one aspect of the result, and I guided it, right? So it's not smart enough to actually do everything, right? No model is, right? It was able to get the trend pretty accurately, more or less, right? It was able to remove the seasonal cycle. It accounted for some gap in the data. It got the units correct. It removed uh, the ice sheets, the oceans, right? Uh, and it was also able to do the trend map. Okay, so it was able to compute trends at each location, plot them in an intuitive way, and of course, again, I helped it with the prompt. But the challenge was for that model, that this small model that runs on my laptop offline, to actually follow the instructions that I gave it uh, to the T. Uh, and it did. So that's all I wanted to tell today. So again, I have a lot of thoughts on about a lot of aspects of AI, and hopefully I'll make more of these videos and talk about them. But feel free to reach out and discuss with me. And bye.